forgot I was wearing a wire. I'm really excited to be back here again at the National Archives and to be able to show everyone what our joint project has been able to accomplish so far. But first, I'd like to describe a bit of the scientific motivation behind the project. So just about 2 weeks ago, NOAA released its Arctic Action Plan. And the very first sentence of the action plan pretty much captures why we're doing what we're doing. The Arctic is changing, and those changes are going to affect everybody on the planet at some point. And we want to be able to understand how that takes place. So history is the key to understanding change. But in the Arctic especially, and around the world, the data are sparse before the satellite era. So we need to try and figure out what do emerging weather and climate patterns mean in the longer term context. And usually the first question that comes up when something happens, so you can fill in the blank, has this with, say, Hurricane Sandy, with the polar vortex of this past winter, or whatever it may be, that seems like an extreme or an unusual event. Well, has it happened before the satellite era? So in the polar regions before 1979, or a few years before regions to the south. And then what caused it? And that often is an elusive piece of information. So just to follow along with the Arctic example here, this is a time series from about 2000 or 2001 showing the disappearance of the multi-year ice in the Arctic. So this is the thick ice of 3.5 meters thick it used to be. But this old thick ice is disappearing particularly fast, but you don't hear this so much in the public sphere. What we normally talk about is the overall extent of the Arctic ice that it's coming and going, mostly going. You see that in the news, but the loss of the old ice is actually the more important piece of the puzzle here. And just for an example, this is the old ice that was photographed in 1978, and this is our polar webcam from last year. So these are just 2 points in time, but you can see what old ice used to look like. It's very different from what the North Pole looked like last year. So so what this is the annual cycle of melt and freeze north of Alaska. So in the Beaufort and the Chukchi Seas, it's derived from passive microwave. The first curve up near most of the ice, that's the first 10 years of the satellite era. So it's the ice concentration in the Beaufort Sea north of Alaska in the 1980s. The last curve is the last 10 years of microwave data showing the annual cycle of melt and freeze in that part of the world. And you can see it's moving from mostly ice to mostly water. And it's also shifting in time where there's more open water sooner in the year. And this is important, especially in the spring, because open ocean warms much faster and much more than ice-covered ocean, and it stores more heat. And this is an example from 2007. This is a SST composite derived from satellite. And there's water there that has never seen that kind of temperature in the summer. Back in the day, that all would have been under ice and not exposed to the sun at all. Yep. Went too far. So the result of that stored heat is you end up seeing these huge temperature anomalies in the Arctic in the fall. And you can see on the one side, this is a temperature record from reanalysis, which I'll explain, but you can see it's getting warmer, and most of that is coming where the ice has gone away. So that's the result of all that solar energy being absorbed by the ocean and then re-emitted to the atmosphere much later in the year than it used to. So that's a topic of real interest now because of the question of whether that's causing disturbances to the atmospheric circulation that are felt at the mid-latitudes. So is there something between this and Hurricane Sandy? Is there some linkage there? So that's something we're working on now to try and understand. So we need to to get to these questions, so the baseline, we need to transform old data into big data. We need to move from, in climatology, we are moving from using data and simple statistics to understand things toward using supercomputing technologies to analyze data in new ways. But to do that, we need sub-daily resolution data. We need hourly or synoptic level pressure data in particular for as long as we can get over as most of the Earth as we can find it. And then we need to convert the old data into a digital format on a massive scale. This is what old weather does. So, as far as the goals of the NOAA-NARA joint project, these things are perfectly overlapping, actually. My main objective is to get to the data, to recover as much weather data as we can from the logbooks. NARA has a real interest in the preservation and public access of these records. So it's a perfect match where we can image the records and get the data and accomplish the preservation and public access mission as well. And then we both share an objective to develop citizen engagement in science and history, which both having this stuff online and through our old weather project is a major, it's a really good way to do that. So what are we doing specifically? We're imaging all of the logbooks that we can of any US ship that ever sailed into the Arctic. We've done 43 ships now. I think there's about 100 ships on our list. Some of them are short, some are long. But I think by the end of this funding cycle next year, we should have about 500,000 pages of logbook manuscript photographed. And then we work on transcribing it through old weather, and then it gets integrated into the standard global data sets that every climatologist and scientist uses. So what we're really doing is we're building a virtual time-traveling weather satellite. Because by doing this, we can get the same kind of information a satellite gives us, but long ago, before airplanes were invented. And just in case you think I'm joking, that's called sparse input reanalysis. This is the state of the art in climatology right now for using surface observations. And what this shows is the explanation or the cause of the 2012 record melt in Greenland. And so this paper is actually in press right now. It'll be coming out in JGR Atmospheres in a month or so. But what this is a reanalysis, but it uses all the satellite data. It uses everything we got to throw at the problem, fully integrated. And so this is the same idea, but in 1889, when there are no satellites. And so using the surface observations and a supercomputer over at DOE, we can generate these fully reconstructed depictions of the atmosphere for any 6-hour period for any year as far back as we can go, which right now is about 1870, but I think 1850 is a reasonable target to be able to do this. And this is the same thing. So what Gil, who's on the project, and colleagues have done is they saw the big melt in Greenland. They asked the question, has this ever happened before? And so they start looking around. They know that there's radar data from Greenland that show a melt layer around the 1880s, so they started looking at that. So we know there was a melt event. But with the reanalysis, we can go and see that the causes are actually pretty similar. It is the combination of a continental heat wave and these atmospheric rivers, which carry moisture from the warm part of the Gulf of Mexico and the continent, and take it up to Greenland where it melts the ice. And so there's a very, I would say, a straightforward explanation for what's going on there. But it is a very rare event. The next nearest one after that is during the time of the Vikings, as far as we can tell from the ice core data. But what the reanalysis does, it allows us to diagnose what it is that caused that event and put it in a long-term historical context. Now, we can also do other things, like try to understand why the winter of 1947 was especially cold in Europe, because whenever there's a especially cold winter in Europe, people want to know why. And with the reanalysis, oops, sorry, back up. I forgot I have to do this. So I'm going to show a couple of animations online, so there'll be, hopefully there won't be too much of a delay between the, okay. So this is what the reanalysis does globally for 1947. So you see, we have enough data to cover the northern hemisphere pretty well. There are more clouds in the southern hemisphere because there's less traffic. So that's a goal of the project, is to try and get more data further south. The other thing to remember here is that the echo of the Second World War actually goes out until 1948 or so in terms of low ship traffic and poor commerce between nations. And it took a few years for the damage to be repaired and regular commerce to resume again. So that's part of this issue. But as far as the physics of the cold winter go, it's because of high pressure intruding over from Siberia and blocking the flow of warm air from the Atlantic. That all ends up in the Arctic instead, but Europe has a cold winter. Okay, so I'm going to. So it's not just weather. It's way more than weather. In terms of history, we have, for the first two phases of old weather, we've digitized about 86% of the Royal Navy movements for the First World War from before 1914 to about 1922. And from that, so we have all the weather data, of course, but we also know crew names. We know the names of the missing and lost. And surprisingly, for the Royal Navy in the First War, that was not a complete, it wasn't completely and well known after the war. So I think there's some new information added there. We know who's on the sick list. So when the Spanish flu broke out, we can see very well how that affected the whole fleet, because the numbers on the sick list go from 2 to 200 in a couple of days when the flu hits the particular ship. Then we know all kinds of other things, who's in the brig. We know what kind of food they're eating, who's dropping the paintbrushes overboard, how much fuel is consumed, ships met, whatever interesting events old weather volunteers see ends up in the transcription. So if it isn't fully transcribed, we at least know what page it's on, so you can go back, and if you're interested in it, you can transcribe the whole entry at your leisure. And it's all on a daily basis. So it's a phenomenally high-resolution historical resource that is unused yet. It's brand new. And this is what makes it all work, believe it or not. This is a log sheet from the Bear, the day they discovered the Greely party in 1884. The Greely expedition was one of the ones that went out during the first international polar year and ran into a lot of trouble, and not everyone survived. And so the Navy went up to try and rescue as many of them as they could, and that's the event happening here. But during all of this, in fact, there are very few gaps in the observations that we've seen so far. The Navy, the British Navy, the US Navy, Coast Guard, it doesn't matter what's happening, somebody's filling out this logbook and they're putting the weather observations every hour. The only problem that we've encountered that I know of is when the guns actually go off, it messes up the barometer. So if the ship is in battle, you have to use the barometric pressure with a certain amount of caution because it gets deranged. But other than that, it is as regular as clockwork, which means that we have this awesome resource. But how do you get all these scribbles turned into data? And this is the problem. And this is why we have old weather. So we put the logbooks online. Volunteers come and help us transcribe it. They help us with the data. They get a shot at the remarks pages because it's really fun and it's interesting and it drives their passion, and it works out for everybody. This is what it looks like. This is a little bit mesmerizing. Be warned. I won't play it for too long. So this is what the transcription from the log of the Jeanette looks like. And you'll see, I'm gonna advance a little bit so we can get to some weather data, but we get everything that's in the log. Every detail, every page, every year, from the beginning of the history of the ship to the end of the history of the ship. That's what we get. Okay. So far, since we launched the Old Weather Arctic phase of Old Weather 18 months ago, we've transcribed 1,081,641 weather reports from, that was March, I think we did that accounting. That includes a lot of numbers of variables, tons and tons, but also many thousands of historical events. But more importantly, you can see in the maps here that we're rapidly filling in a big hole in what was our global resource for this period of time. From 1880 to 1909, there were essentially no observations in the Bering Sea or the Arctic. The dots here are actual individual observations. That's if a report was made, it's in the database, it shows up as a dot. It's every single one. But now you can see this is only 2 ships that we've been handling, and we're getting lots and lots of data that wasn't available before unless you came here. All kinds of things, all the kinds of things that I was outlining are now available for the period basically after the purchase of Alaska, up until after World War II. So it's going to be a whole resource, a whole reflection of what happened in Alaska, and things like the relations between the revenue service and the native populations and whalers, and the suppression of the alcohol and gun trade and all that sort of stuff. We're going to have every detail for every day related to all of that stuff. So you find, through the project, we sort of rediscover all these extraordinary stories, like, Roald Amundsen coming on the ship, or a typhoon signal being spotted on shore, which, as a ship captain, I can tell you is unsettling. Scattered wreckage, rescues, finding the folks, the servicemen from the Army who didn't survive the Greely expedition, all that sort of thing. It's all there. So one of my favorite examples is a log series from the Jeanette. It's an amazing story. So this was an expedition that was sent out in 1879 as a joint venture between the Navy and the New York Herald. And the idea was they were going to go up through the Bering Strait, take advantage of the warm currents flowing the Pacific to find a weakness in the ice, and then sail on to the North Pole, where the idea was there was an open polar sea. The failure of this expedition probably put the end to any idea that you can do speculative geography. You can't just have an idea and have it be true. You got to go there and see. And so that's what happened to the ship. They got stuck in the ice almost right away. They drifted for nearly 2 years, and they were crushed, and then there was this whole saga of survival for some people to get back to land. The upside was they inspired Nansen to try it again with a specially built ship to see if he'd actually drift over the North Pole using the motion of the sea ice. So now we have the data, and we can look at it in a new way. We can put it in context with modern resources. We can use modern techniques to see it, to see what it's doing. So the map here, this is the track of the Jeanette overlaid on all the virtual tracks for modern, since we have satellites. So we generated virtual tracks based on buoy data and plotted them all too to see how it compares. And you can see for some cases, they go pretty much the same way the Jeanette went. Other cases, they head off to the North Pole, which might have been nice for them, had that occurred to them. But what I'm not showing here is that all of the other instances, there's more than half of the instances, the virtual buoys just got kicked right back out. They went back to Siberia. So, things are different. We don't, and we don't know how that relates to what happened in the Jeanette, but it does seem like they were kind of unlucky, because there was a 50% chance when they went up there that they would just get bounced right back out again, or they wouldn't get stuck, or that kind of thing. And then I want to show you one other thing here. This is the track of the Jeanette animated with the ice from 1980 laid in. And so that you can see the red dot there, that's the Jeanette, and we're showing how the Jeanette moved in response to the ice dynamics that were prevailing on that trip. So you see the first year, it just wanders around more or less near Wrangel Island. And in fact, they do a whole year, and they come back inside of the island, and everyone's despairing because they've just gone through this whole year of misery, and they're right back where they started, near Wrangel Island. But then the next year, something different happens. After Christmas, things start to move, and they just take off across the Arctic. And they just go and go and go. This is the highest drift rates of the whole period. And then they get there, they're crushed, just before the thaw. I mean, the ice is melting, there's melt ponds everywhere. If they could have held out a little bit longer. But like so often happens, there was just one piece of ice that had it in for them. They just came over and squashed them, and they sank. And then they had to walk from there and drag their boats and sail to Siberia that way. So now we can say, well, why did it go slow one year and why did it go fast the next year? And the easy top of the line answer is that 1881, okay, I'm going to get a little geeky here, that was the most negative Arctic oscillation. So that's a pattern of atmospheric circulation that drives the movement of the ice. It was the most negative phase one that we've ever seen up until 2012. So there's an interesting sort of science piece of it too. So what was the atmospheric circulation doing then? It was turning up the circulation of the polar ice, and that's why they took off that second year. So this is something else I also like to relate. So coming here and being able to see the documents themselves, the actual documents, it almost gives me the shakes, because I know DeLong is the one that kept the log. That book was on the ship for that entire terrible voyage. And then they carried those logs from the sunk ship all the way home. And this is not an insignificant feat. These books, as Mark can tell you, are enormous, gigantic folio things that weigh about 50 pounds a piece, and there's 4 of them. And then there's the personal diaries and everything else that they brought back. So they're packed in that box that they're carrying on their backs after their ship sank 2 months ago onto the shore, and they're not going to let them go. And so that box was found next to the bodies of the DeLong party a year later by Engineer Melville, and he picked them up. But that wasn't the end of their journey. He gave them to 2 Russian couriers to bring back to St. Petersburg. They get stuck in a flood on the Aldan River and end up in a tree for 2 weeks. And they practically starved to death up in the tree protecting these records. And so when the flood subsides, they come down and they continue their voyage, and eventually they get back here. But when you have those books in your possession, it's really amazing. And here's a picture of our former administrator looking at those logbooks at the launching 18 months ago. So the other thing about old weather, which is amazing, is that it's definitely a grassroots, bottom-up managed kind of thing. Like we don't tell the volunteers what we want. They just think up stuff and they do it, and it's brilliant. Like all the reference pages that transcribers need to access the logbooks and understand who the quirky log keeper is and how do you read that E or whatever you can't read, and all these things. These are all built by the volunteers. All the databases behind this, everything. And it goes on the forum on Old Weather, and there it is, and we can use it. It's a great resource, and you can see all the different formats and all the different logbooks that we have. It's brilliant, and that is what our citizen scientists do, and it's just, it astounds me every time I talk about it. And the other thing here, especially for the archivist types, now we have every page that is handled by Old Weather is transformed into a different kind of object that's now searchable. It's transcribed. We know where everything is on every page. If you want to search on names, things like that, we now have a resource that you could convert a unsearchable handwritten manuscript now into a fully accessible resource, as if you could OCR it. And it's the same kind of, you could bring the same sort of search capability to that collection now that you could if it was printed and OCR'd, which again, I think is an amazing step. And it opens all kinds of doors for how the data can be transmitted to the public and used. So the other piece of this is the citizen history. Gordon Smith's our collaborator in the UK. He's an amateur historian. He got involved in the project because his father was lost during the Second World War in the Royal Navy, and he wanted to know more about what happened and what it was like, and that sort of got him going on trying to document what happened, especially where records were sparse during the First World War, that kind of thing. So he has his own facility over in the UK, navalhistory.net, and that's where our editors put all of the edited transcriptions from the remarks pages. So there's a place where you can just go and read the log without having to look at the handwritten manuscript. And this is also a completely volunteer accomplished product. And the other thing about that is, as folks edit the logbooks and put it into the format for navalhistory.net, it's an opportunity to add all the links that they found either through their own research or because we have the pages now to the logbooks, we can link every day back to the logbook that it came from, pictures related to that day, anything you can imagine that would relate to that page and make it more useful as a research product. Those links can go in there, and then you've achieved a sort of virtual archive of the work Old Weather's done with work other people have done. And this is what I'm talking about with the Albatross, because the Smithsonian has all the field books scanned. We have all the logbooks. The field books don't have the positions, the logbooks do. So to make full use of both of these things, you have to have them put together. You have to get the link to the field book on the link to the logbook so that you can then scientifically make use of whatever information that is, trawls or whatever. And that's true for every ship that we handle. Where there's a resource, we need to be able to make those linkages again. A couple other things that we're doing that are, I think, really fun and fascinating is we're also scanning photographs whenever we can find the time and get someone to help us out with it. And these are some examples. Most of these were scanned from the Coast Guard Northwest, Coast Guard Museum Northwest, which is a fully volunteer-run museum out in Seattle. So a lot of these pictures were just in folders there under their care. So we went and had a student who's a Coast Guard reservist herself, went to the base and scanned a few hundred of these pictures, which we now have available for Old Weather and for our site as well. And you see there is a poster she did as a capstone project. She was an high school student as well as being in the Coast Guard. And so that was her 2-semester thing, was to scan these and put them into a database. We're doing the same thing this semester. We ended up with about 2,500 portraits of Coast Survey personnel from the beginning of the Coast Survey to after World War II. And so we have a couple of students at University of Washington's iSchool building a MySQL database with all the, it'll have the links to the pictures and all of the metadata so that we can serve it out as a gallery, a searchable gallery. So if your ancestor worked for the Coast Survey or you have some connection to the Coast Survey that you want to find out about, you can now search and find pictures of all those people coming to our website soon. We also do other separate student projects. If you think of anything that, if a student thinks of a thing that they want to do, we try to facilitate that. This is actually a high school project that we're doing with a high school in New York, Commack High School, where they're evaluating the screen bias. Okay. Anyway, the HMS Plover went to Barrow in 1852 through 1854 and collected all its temperature data, but they didn't use a standard screen, so we don't know whether the data is worth anything or not until we find out. So the high school students built a replica of the screen that they actually used, which we found described in an article published back in the day. We built a new one, we put a modern thermometer in it and shipped it up to the NOAA observatory where they set it up next to the standard thermometer. So we have 2 years of data now parallel, the old shelter, new shelter, and they're working up that right now. So we can say, well, you can use this data under certain conditions or not at all, or you can apply corrections so that you can see where those observations would fall in comparison to modern data with some sense of confidence that you're not just making stuff up. And I think that's brilliant. I'm very happy they got a first place in their local Science Bowl thing. If anybody has any students, we can do more of these than we are right now. Okay, changing gears a little bit. The next thing is going to be building a daily historical sea ice product. A lot of the ships that we're handling now have, like the Bear, they have sea ice observations in them. We also have data from whaling ships from the New Bedford Whaling Museum. We're pulling a lot of information out of them, and we're going to try and build a database that will handle access to the unstructured data because, well, the maps you see here are derived from a former experiment looking at sea ice. Sea ice was a byproduct. They were looking at whales, but all they had to digitize with in the 70s was IBM cards. And you can't key punch a description on an IBM card. So we know where ice was and where it wasn't, but we don't know anything more because that data couldn't actually be ingested back then. So we're going back imaging and doing an unstructured transcription project on the sea ice observations, which will then allow us to build a database related to this unstructured data, which then will build some sort of visualization and reanalysis technique to use. The other reason to have this is because we have a project running with another laboratory using a model, a sea ice model, so we can run that backwards with reanalysis and see if the model is getting what it's supposed to get. So it's a ground truthing resource for modelers, which is very valuable. Now, where do we go from here? Since we got this great project started, now nobody wants to stop. As long as the National Archives will keep us, and we can keep enough funding going, I don't see any reason to stop. I mean, there's millions and millions of observations. So, we're looking through the records and we see, World War II is one of the most uncertain periods of all in the 20th century, and only a fraction of that data has been digitized, like something less than 5%. There's a lot of data to get. It would be really a great data set to generate. Some of it is handwritten, and some of it looks like this. It's a typewritten log. And we think, we're in discussion with a software company now, but we think we can build an adaptive OCR engine that will handle this form, like a custom OCR engine that will get relatively high return, something above 90% on selected data. And then someone has to look at it still. So I think our idea will be to attach it to our old weather program, and we'll do adaptive OCR like old weather. This will be a couple of years down the road, just so you know. Don't get nervous. But it's something that we're thinking about, because if all you're doing is checking the scan, you can generate a lot more data than having to actually transcribe it. But it's just as important a task, because getting bad data in the database is almost as bad as having no data. So we do that, and if we do that, we would follow the same protocols we have now, where we would photograph, scan, OCR, all of the records related to that ship, like the remarks pages, battle diary, the day-to-day operations, whatever is considered a set of that logbook, we would handle all of that and turn it into this kind of thing. So then the entire, I'm just going to wildly imagine, but you could have the entire history of the U.S. Navy during the Second World War and the Coast Guard in the same kind of daily searchable resource, where if you wanted to do any kind of research related to that data, you can just go online anywhere in the world and find what you want. And it will be digital. You can analyze it with a computer. You can search through the entire volume of Navy records in a nanosecond to find out whether your relative is somewhere or other, or some other event that happened or anything like that. So this brings me near the end. This is a remark that Melville made. So Melville was the chief engineer of the Jeannette, and so he was on that voyage. His boat was the only one of the 3 boats that left the Jeannette to survive, and he was the one that stayed behind and searched for a further year after he was rescued, searched all over the Lena Delta and the tundra in Siberia to find his fallen comrades. And he was not going to leave until he did, and eventually he found them. After a whole nother year of privation, sledding around Siberia with not much to eat. So he's the one that found the records. But then after he got home and found that the Greely expedition was still lost in the Arctic, he volunteered to go back to the Arctic and find the Greely expedition. So then he went on either the Thetis or the Bear, I can't remember which ship he was assigned to, but he went back to the Arctic again and contributed to that search, and then found again, 2/3 of the Greely party had starved to death. But we had the records, and all the equipment that they had came back. And then he's reflecting as he's writing his book about his experiences in the Lena Delta. Well, what is the scientific value? We can, that these men basically gave their lives for, or the ones that survived. What's the value? It can only be estimated after their observations have been used, after they've been reduced and analyzed. Otherwise, they're just on paper. And all of the effort that those men went to is wasted. But he recognized it would take a long time. I'm not sure he thought it would take 130 years. Some of these records were the first people to handle them since those books were closed 100 years ago. And now, the meteorological work of generations of naval officers preserved here in the National Archives in this building have new scientific value in our effort to understand changing climate. We just need to get them digitized. Thank you.